Can you hear? Can you hear? Testing, testing. Yeah, good.
Yeah, we do hear you well.
Great. So I want to welcome you all here today. This is the second in the series of our events here with the IAAI, the Digital Innovation Pavilion at COP28. I'm Truman Siemens, the founder and CEO of Linux Foundation OS Climate, and delighted to really launch one of the great, most important milestones since we founded OS Climate 4.5 years ago, and that is the what we're going to present here today, and the full opening up to global collaboration of a somewhat of a moonshot project that began 4+ years ago, and the team that started this is here with you. We are setting forth nothing less than the ambition to build, through the power of community-based open source collaboration, the most effective tool for decision making around the transition in terms of business, in terms of finance and investment, policy making, and economic development. It's a bold vision. It's one that we believe through shorter term outrageous ambitions that we can meet. And I think that the progress that you've seen, that you'll see demonstrated here today, will demonstrate that we're well on our way, and that it's worth jumping in. One of the main purposes of what we're doing here today is to reach out to colleagues, including some that are in the audience today, with open arms to join in collaboration to build this further. Normally speaking, at OS Climate events, I spend a few minutes talking about how community-based open source collaboration works. In the interest of getting right to the subject matter, I'm going to defer that to questions, and we have ample recordings and the like online to describe that. But let me just do that very briefly to say that that we're using an approach that has resulted in the vaccines that you all have gotten in your arms, that has resulted in the major breakthroughs in genetic medicine through the Human Genome Project, that has resulted in the Linux operating system, which operates 100% of your phones, most of the transportation systems that you took here today, huge swaths of the financial system, only possible where multiple different organizations, users and providers of technology are joining together to solve common problems that are too big for any one company to solve alone. So we do that through the Linux Foundation, which is the largest host of technology, open source and open data projects globally, that over the last 20 years has developed some of the best methodologies for supporting those community-based efforts through 900 projects, and projects that have been touched and built with the hands-on keyboards of more than 540,000 individuals. So the other thing that I'll say in laying the groundwork for this session today on the transition scenario analysis project of OS Climate is that part of the roots of OS Climate lie in trying to do very crude scenario analysis modeling to help my consulting clients back around 2010, where we took efforts to the end of Excel and Access and tools and broke them, and required a team of analysts a couple of weeks literally to go through the steps and stages, feedback loops, to come up with sort of see a bit forward into the future to make major bets, in this case for a large chemical company, in hydrocracker type projects, in advanced plastics and the kinds of things, looking down at markets 5, 10, and 20 years down the road. At around the same time, McKinsey was developing a similar set of models that were sort of the grandchildren, let's say, of the abatement cost curves, which many of you all are familiar with, and they too broke Excel. We'd reached the end of what could be done without a modern software approach and without really serious compute. And you're going to hear today about really taking the whole integrated assessment approach to decision-based modeling to the next level and beyond. And you'll hear about that from Capgemini in their role as the leaders of the open source project that then will also be the basis for commercial products in the marketplace. And also, so that's from Vincent Charpiot and Thierry Chevalier, and our colleagues joining remotely, Valérie Pereira on our board, Marie Morer from the modeling team, and the head of product for this project and Business for Planet Modeling, Mathieu Mo. So without then you're in terms of the compute that it takes to make this all happen, we're very grateful to have with us Nelson Gonzalez from AWS, and AWS. There would be no OS Climate without AWS enabling all the work of our community and the dozens of modelers, software developers, and data scientists working over the last years. So I'll step back and turn it over to Vincent Charpiot.
Thank you, Truman. Hi, everyone. I will not say too much, but what I'd like to share with you is two things. One, large corporation and large clients, organization that all of you are serving today are facing a huge challenge in terms of climate transition, which is no longer a kind of nice to have conversation. It's a business critical conversation because they now need to decide, number one, where to invest next. Truman was talking about short-term, long-term. We are in the middle of that conversation today. How those companies should reinvent themselves to take planet into account in everything they do. And of course, when you talk to a product company, but also to financial services institutions, climate and the transition risk is embedded into everything they need to look at, include. And that's not only their clients' expectation, but also their employees' expectations. That's one. And what we have seen and working closely with OS Climate, that there is no unique solution today to tackle that system. And if you look at it from a data standpoint, clients need to cope with their own data, open source data, of course, with the power of the community, as well as regulation or local, regional, country level data. So having an approach when we can integrate and propose, I would say, almost off-the-shelf scenario modeling platform is definitely an accelerator, but it could also, if you leverage it the right way, be a business differentiator. I will hand over to Valérie if you want to say a few words on the OS Climate partnership.
Yeah, thank you, Vincent. OS Climate is about bringing a part of the answers that to the question you just raised, Vincent. It's about bringing also solid foundations for a platform, and of course validated by the, I would say, Linux purpose, way of sharing this open platform. And of course, this solid foundation offer two different level, I would say, of services. The first one is the access to models in order to predict, to anticipate the impact of the climate change. You said it's short-term is probably already managed or being currently managed, but midterm is the real question, how the big companies are able to anticipate and provide an answer to the strategic question, where to position the assets, the plans, or any other elements to produce their value. This is the two pillars: solid foundation on the platform, and of course the second level, the access of the models. And if we go further, we all know that the insights are coming from the data. And if you are able to federate the data from pure, I would say, the earth, plus the economic data, plus the ecosystem of your company, then you have a 360 view to answer to this question of how to invest in midterm, how to anticipate the climate impacts, and being sure that we will be more resilient, I would say, at company level, but as well at a country level or worldwide.
Thank you, Valérie. Truman was mentioned scale, and we have Nelson from AWS. Can you elaborate a bit on how you see that planet modeling scenario at scale?
Sure. I think the challenges that are posed by particularly decision support around climate risk and particularly its outworkings in things like food security or health and climate, climate and health, require not just scale, but complexity. And I think what really excites us about our collaboration with OS Climate is I think we share the commitment to both scale and to innovation. Certainly the cloud, I think, is absolutely necessary if we're going to reach that scale in a way that's secure, cost-effective, and also carbon effective, but also in a way that allows us to innovate. I think taking away the undifferentiated heavy lifting of developing the data, the infrastructures, the modeling, et cetera, is critical. And then we need the last mile partners like those in the audience, the applications that Capgemini has in terms of consulting and so forth on top of that infrastructure. But without that kind of cloud infrastructure scale, I think a lot of this modeling is really impossible. And I think the cloud not only brings that security, that efficiency, that cost effectiveness, the carbon effectiveness, but also I think the ability to innovate, because once we take away that undifferentiated heavy lifting of needing to create that infrastructure, we then have space to think about how to address the challenges and opportunities that something like climate risk gives to us. And I think in particular, for us at AWS, and particularly my team that focuses on social and environmental impact with advanced compute, we are very interested in how to apply simulation to complex adaptive living systems, how to think about agent-based modeling in new ways, certainly how to apply generative AI, which we think is one of the most powerful tools for equity that we've seen in technology. I'm happy to talk more about that later, but I think scale enables us to think about efficiency, but also innovation and the problems that decision support, particularly for new personas in the marketplace. Something that really drives us is the fact that you now have chief heat officers, regional information officers, heads of climate and health, who require the kind of business intelligence that, say, an air traffic controller or a hedge fund manager take for granted. But we're asking them to use their guts, right, and their good education. It's not enough, right? We need to actually empower them to serve their vulnerable communities in the way that we do any other profession. So we're excited to bring the scale, the innovation, and the security.
Thank you, Nelson. We'll over to the demo now. I think that Thierry needs a cable. It's not wireless.
So be with us a couple of seconds. It should be back. Okay. So let me start by introducing what we call WITNESS, World Environmental Impact and Economic Scenario, which is an integrated assessment model. So we'll hear about WITNESS, which is a framework for, let's say, model of the world. SOS Trade, which is the underlying simulation platform that is running this framework. Capgemini Business for Planet Modeling, which is a commercial offer to provide services around that. OS Climate, which is a project in Linux Foundation, that is where this open source project is developed, and Linux Foundation, I'm not introducing it, everybody knows. Okay, so first, it's a system of system approach, which means you have different systems, macroeconomy, energy, material, natural resources, environment, and so on. Each can be subdivided into subsystems. And these subsystems interact. And one of the specificity of the platform and of the integrated assessment model here, all the integration and feedback loops are handled and converged at every time step. When you go from, let's say now to 2100, which is not always the case in many of the integrated assessment simulations. So just to highlight the importance of such coupling, I will use two of them. One, which you see here, you have a curve, this exponential here, which is valid from middle of last century to now. Primary energy production, world GDP. So you have a very strong coupling that is validated since middle of last century. And these are the prediction from the main guys from International Energy Agency, IPCC, and so on, which people call green growth. Okay. And when you look at it, you say, wow, do we believe in such big decoupling? And when you look at their model, you see that this coupling, in fact, is not really done in depth. Another one, which is more on the human side of it, is between climate damage, environment, damage impact, and population. So here, this curve is just showing that basically when the temperature is very high and the humidity is also very high, you die. You are sweating, but your sweat is not evaporating, so it's not cooling you, and you're dying. This is what was measured in terms of temperature last year in India. It's a real one. Huh? And this is the growth average growth in temperature in the last decade. So you can imagine where we go. And again, this coupling, I mean, most of the integrated assessment model already have no population model. Okay. Scalable, I will not go. I think Nelson made it very clear. It's completely cloud, completely scalable. It's open source, but it's full what we call DevSecOps, which is so it's DevOps, which means you as soon as you have written your model, in a matter of hours, it's published, it's integrated, it's coupled, and the sec in the middle is just that in the development pipeline, you are checking that you have no rogue code and no vulnerabilities. It's cooperative, which means you can have specialists of all these systems, economists, demographics, people specialists about ecosystem and nature, climatologists that can cooperate, look at the same solution, not at the same part of the solution, but at the same problem together, make comments, validate. And that's it. Let's go for the demo as an introduction. So this is how it looks like. It looks like very dark on the screen here. I don't know how it is in a... No, I don't. There is some... the system is allergic to it. Ah, good. Back again. Okay, so web browser. You have a set of menu where you have the list of your studies, some ontology, which is giving you all of the model processes and parameters. Basically, we're using semantic interconnection between the model to help making it quite automated how models are coupled together. Group management, it's cooperative, but to be really cooperative, you have to allow people to share what they want to share and to keep secret what they want to keep secret. So you can have groups and encryption for part of the scenario. I will not enter in detail because it's not the purpose here. So web-based GUI, the study is here. For each study, you can see what is the status in terms of is it computed or not? Has it been validated or not? So here you see some elements are validated, some others not. You can see who is in the study with me. I'm alone in this one, but we'll see a little bit later one where will be several in the same. A unique ID, a unique a permalink for the study, so they can reference it and being sure if I send it by mail to my colleague, it will pinpoint the right one. And after that, you have all the different models. So you will recognize, so here it's the global evolution of the different types of energy in terms of how much they are emitting and how much energy, the price per megawatt. And you see how it evolves over years. You have some Sankey diagram on the global evolution, and you will recognize models for the land use, the agriculture. So you have the different parts of the land used by forest, by agriculture. For agriculture, you will have it separated between the different culture. You can have white meat, eggs, potatoes, depending on how they are emitting and how much food they produce. You have the macroeconomics. classically with the breakdown of energy investment, which is what we are looking at this model. There's a carbon cycle, carbon emissions, the damage, where you have the environmental damage, but you have also, oops, you will see it on the population, the damage on the people, the temperature evolution over the years, the policy, which is a carbon tax, the population, and including the evolution in terms of age range and instruction level, and the human cost of global warming per year, the investment distribution, which is how, if you remember the initial diagram, economy is generating some money, and it makes some money available to be invested in energy for producing energy. How do we split this between the different technology available, basically to maximize the energy you produce and minimize the carbon emission, which is an optimization problem. The energy mix, with the evolution of the energy mix over here, where you have different type of generation, methane, hydrogen, biogas, syngas, fuel, solid fuel, electricity. For each of these models, you have what is generated. For all of the models I presented to you, you have a complete documentation that is explaining what this model is, what are the equations, where do we find the data that we use. You have the carbon capture, carbon capture, you get it out of the emission device or directly from thin air. You have the carbon storage, again with various methods, and you have several resources, oil, coal, copper, and things like that. You can have this in multi-scenario. So here I have different scenarios with different policies. Each of these scenarios, you will find the same type of witness I was just showing you. And then you can have the post-processing with some Pareto between the different scenarios, like welfare versus temperature increase, or welfare versus CO2 emission, which will give you the kind of boundary you can reach in between the different scenarios. Here in this scenario, we can see that if you put the CO2 tax very low, it's not good. But if you put it too high, it's not good neither, because it will kill the economy. So you don't get enough money to fund renewable energy. Okay. Finally, we can see that we cannot see it, but here, but we could see, if you look at the documentation, that most of the model, if not all, basically it's equations. You are using equations, and these equations is typically what will allow you to make the what if effect, because you know exactly in these models where each quantity is involved. So if you want to tweak that, I'm generally using the classical example. If you want to model what is the impact of war in Ukraine, then you could, in a regionalized model, you could say, okay, I will divide by half the exchange between Russia and the rest of the world. I will reduce by 30% agricultural production of Ukraine. Then what does it get? If it was purely black box model from data analytics, I don't know where I can find these levers to make the what if. And as I was discussing, this is not for making prediction of the future. It's very good to predict what cannot happen, because, for example, you don't get enough copper, or because you don't get enough energy. It will give you a range of possible stuff, an envelope of possible things. And that's what the company will use to develop their strategy so that it is robust among this range. I will hand over to Marie so that she can present. Ah oui, il faut qu'on refasse du... Can you switch, or do I need to give you back the cable? Okay. She will present several scenarios that were done using witness. So you will see you have one scenario that is where if we go full fossil, as we say, and to make things simple. Another scenario which is mixed, and a third one where we try to do what we can best to minimize the temperature rise. Marie?
Yes, can you hear me well?
We hear you, but we don't see your screen. You need to share. Yeah, now we see your screen.
Okay, I'm sharing my screen now. So we are going to start the demonstration by the simple use case. Let's imagine a world where there is no damage on the economy due to climate change. So in that case, we are going to invest only in fossil fuel energy, as there will be no incentive to invest in renewable energy. And this, in our energy model, will result in, if I find, yes, in an energy mix containing almost only fossil fuel. And so this energy will be an input, as Thierry was saying, of our macroeconomics model, and it will then simulate stable growth in the economy. So this is a GDP of around 2% per year. So this is a nice use case, but as you can imagine, as we are using a lot of fossil fuel, we will have a lot of CO2 emissions. So this is a graph showing the CO2 emission in that case. You can see that we multiply by, I think, at least 5 times the CO2 emission, and it leads to climate change. And then in that case, we have a temperature increase of 4.5 degrees at the end of our period of study, which is 2100. And so we also estimate that in that case, the unaccounted damage in the economy are of about $80 trillion, which is around more than half of the current GDP. So what will happen if we take into account this damage in the economy? And that is our next use case. So in that use case, we took some different assumptions. As there is some damage, we will have some incentives to invest in renewable energy. So we took a kind of business as usual scenario, meaning that we kept the distribution of investments between renewable and fossil energy as of today. It will give an energy mix looking like this, so almost half renewable, half fossil. And then you will see that we will have way less emissions than before. And so we will have a temperature increase that will be only 3.4 degrees, still a lot. But as there is climate damage, you will see on the economic, so on the GDP, you will see a growth for the first half of the century, and then degrowth due to climate change and climate impacts. And so the next question is, can we have a use case where we limit this damage? So can we imagine a scenario where we reach zero emission in 2050? And this is our last use case. So for that, we invest massively in renewable energy, but also in carbon capture. Our energy mix will be different than before. We will have almost only renewable energy. So you will see some fossil fuel until 2060, because we have no stranded assets here, meaning that we do not decommission fossil assets. And so we will also, so I will not go into detail of the carbon capture, but what I can show you is that we capture a lot of CO2 in that case because we invested massively into carbon storage. And then we have a total CO2 emission that reach zero in 2050. And you can see it on the economic model that it is way better than the case before. So if I go to the case before, it was looking like this, and now our GDP is doing better than before. But the last thing is that we still reach a temperature increase in that case of 2.4 degrees, which is still a lot, which leads me to my conclusion on that aspect. You can see that damage are a key driver in this scenario, and this is our main challenge for next year, to develop further our damage model to be more accurate. A second aspect is that here, what I just shown is only scenario done by analysis, and we could get better results by doing optimization. And this is an ongoing work on our side. And last but not least, on the investment, as you can see in this use case, if we want to decrease massively the emission, we need to invest to shift a lot the investment. So this will have effect on the structure of the economy. And to better understand the mechanism at stake, we must take a step forward in the modeling and modelize the economic sectors.
Considering the cable, Marie, I think you will continue without me displaying something big. So You can move to a case where we have done sectorization, and we'll try to illustrate in this collaborative work, considering, for example, we have 3 sectors here: services, agriculture, and industry. Let's suppose we have 3 people who are specialists, one in industry, one in services, one in agriculture. So let's say, for example, Marie is taking the agriculture and Mathieu the services, and I will take the industry. And let's look how each of us can validate and comment their vision and their part. So you can start, Marie.
Yes, so a quick introduction on the sectorization. You've seen that now there are 3 sectors below the macroeconomics. So, each sector will have its own production function, and the macroeconomics model now is only the aggregation of the 3 sectors. And to be able to distribute the production factors, so energy and investment and labor between the sector, for now it is a user input. So as you can see in this use case, we decided to keep the distribution between sectors as of today. And so I will look at the result for the agriculture model. I'm the
If you
expert.
can show that there are 2 people in the scenario here.
Yes, absolutely. So here you can see
yourself.
the +2, and if I open, I can see Mathieu and Thierry connected to the study. And so if I look at the agriculture model, what we can say is that we see that the production is decreasing, partly due to climate change, but also if I look at this graph, this is in green the demand for energy, and in blue the supply, and we can see here that if we have more energy supply, we could have a better production. So this is my comment on the agriculture model. Mathieu, if you want to go on the service model.
So, yeah. So you have to share your screen, Mathieu. I don't see Mathieu. Mathieu has disappeared.
We cannot hear you, Mathieu.
Okay, it's pas grave. Let's skip. We'll do 2 instead of 3, but that's not the point. I will need to take the cable.
On t'entend. We cannot hear you. So maybe I can do the voiceover and he will validate his own.
Yeah. So here on my side, so I see all the same that Mathieu and Marie are in the study. I'm looking on my side on industry. So basically I could look at industry while she's looking at agriculture. It's the same study, but everybody can look at different parts. And here I can see that I have more energy than I need. So I'm wasting energy. And probably I will do it for agriculture also, because no, agriculture Marie did it, and for services it's even worse. So here in terms of VNV, I could validate my data here. So okay, Mathieu already put too much energy for service here. So I will do it for industry. I can put here some command like too much. And I will validate that. So all this is captured. And after, if I'm looking at the result, I'm reloading, the different validation will appear as green in the area where it's been validated, and there I can see the tracks of the comments. So the network is not very fast because the network is there. Okay. Okay, so here it's, oops, when I'm validating, ah oui, parce que je suis pas reloaded, so I'm not in edition mode, so it's not taken into account. Okay, So basically, and you have the same thing when you, so here you see it's been validated here because all of us have put some comments here. You have the traceability of who validate. It would be the same if I'm making some changes in the input. Every change is traced, who made the change and so on. So that's the end for the demo. Just a couple of comments for the end, and that's it. We were mentioning, and Truman was mentioning that you have some recipes for open source. So the DevOps pipeline is now fully open. We started something over a year ago to make some source code available, but the pipeline for making the DevOps was not yet there. Now it is there. So you can completely contribute, and we have several groups of students who are already working with it. And we are starting the in-depth VNV of the model because we have joined the EIMC, which is a community of integrated assessment model. And there is a complete set of scenarios that will be tested over the next year and will be part of it to have a full academic validation of that. Now that we have something that is not stupid, but we are not specialists in finance, in agriculture, and so on. So now we need to go with the specialists of the integrated model so that they can stamp that. Several of them had a look and said it's really not stupid. Now we want to look in every detail so that we get something that is very robust. And that's it.
Thierry, could you maybe just say, okay, what are the priorities over the course of the coming year around sectoralization and around regionalization?
So the answer is in the question. We are working on sectorization and regionalization. So you have seen sectorization here with 3 sectors, but we'll go up to 10, 15 sectors gradually. And regionalization with first macro regions, European Union, the US, and so on, and then progressively up to land. And one of the things we want to do from a mathematical point of view is what we call smart regionalization or smart sectorization, which means if I want to have something that is at the country level or for one country or even at region level, it doesn't mean I have to do all the world at region level. So I could deep dive in some area and having a management of the rest. So I could have part-time detailing on a global rest that is managed correctly in terms of numerical aspects, so that I'm not losing elements and things like that. And it would be a real regionalization and sectorization. I mean, it's not just a global linear mapping. Huh? It means, for example, things like emission of CO2 will be managed at world level, whereas, for example, economic exchanges between regions will be managed between the regions. So you have some aspects who will go down the flow between sectors or between regions, while some others are still managed globally. So it's really a multi-scale in terms of sector or geographical. And by the way, probably also we are looking for a multi-scale in terms of time. Today, the time step is 1 year, as opposed to 5 years for most of the integrated assessment models. So it's already smaller, but we see if we want to correctly address shocks, we need to be able to have a variable time scale so that we can, in some area, go at the level of the month or maybe the week, whereas in some areas, the year or even 5 years could be okay. So first regionalization, sectorization, and a variable time scale also later.
Great. So let's switch back to the panel format for Q&A. We won't be able to jump into the visualizations and answering questions, but we can handle some of those questions and then take them offline. Great. Well, I can, yes, I'll come up and so you can see me, Truman Seaman. So I'm going to moderate. That's covered, right? So one of the things that I did want to get to is how is what we're seeing here different from the tools and approaches that have been used? And one of the things that I'm going to note for the audience that can't see them here is that really one of the foremost explainers of what's happening in the energy system. A team that has developed the very powerful En-ROADS model is here with us today. But welcome your comments on that. Or Mathieu.
Do you hear me now? Is it okay for now? So yeah, so we have a fully developed energy system that makes sense if it was with a lot of technology. So can you just precise what you mean in your question? Maybe I missed the essence of your question, Truman.
Repeat your question.
Yes, can I? So if you could just talk about what is kind of distinctive about the Witness and SOS trades as opposed to some of the other tools and models that are available.
Yeah, so compared to other models, first of all, we have a very detailed energy model for an integrated assessment model with more than 40 technologies for energy production and 15 technology for carbon capture and usage. That means that we have up to 55 or 60 technology overall where we can invest in, whereas in general, we have much less details in the energy system. Second, as Thierry mentioned, we have a full coupling of models. I remember during the Integrated Assessment Model Consortium conference that people said we do not take into account some feedback loop on the population because we cannot take into account feedback loop with our modeling approach. And what we do is really to couple every model, and we do real loops with mathematical solving of these loops to be able to take all the feedbacks between the different aspects: temperature impact on population, temperature impact on productivity of people, and temperature impact, for instance, on the running hours of the energy system. So we can really go in the details of every aspect, and that's where we differentiate a lot. And the third point is really we have a correct graphical user interface compared to IAMs that are fully batched most of the time, and you do only data analytics, and here you have a full web GUI for your simulation.
Excellent. So let's go to the user and the decisions that need to be made for the transition to sustainability. So Vincent, could you talk about some of the questions that major actors are facing and the kinds of decision support that you can provide?
Yeah. So what we see today, I will take two examples and how we connect that service, platform-based service to a business decision. One is on the financial services sector. If you take a subset of that industry, which is asset managers, today, what they want to see and what they need today for their clients is two things. One is climate stress testing on their current portfolio. That's one. And second is decision-making on their future investments. So how to track finance emission, how to reduce those finance emission, how to have the right return on investment when they create new product for their clients. So they're asset managers, internal users, but also their clients. So that's what two use cases for asset management or corporate investment banking that we see more and more. And when we deep dive into the model that Mathieu highlighted, that brings in a single platform a lot of answers to their multiple questions. Well, until today, they have been struggling to have a single version of the truth, if you want, and they had to integrate multiple solution in-house solution, which creates some black box effect, or with not the traceability that Thierry highlighted, or open source solution, which are partially covering what they were expecting. That's one. The second use case I want to highlight, more to give you a sense on how to apply that output in terms of scenarios, is on the heavy manufacturing, heavy industry sectors, like steel industries, for example. The value of that approach is also to provide them inputs on two fronts. One is input to create digital twins and to really play with scenarios concretely and how those scenarios help them in their real core industry. And the second one is business case, because at the end of the day, especially if you talk to CFO, they want to play with numbers. And that platform allows us as well to monetize and put real business case aligned to the specificity of the clients, 5 years, 10 years, 50 years for some industries, so that they are able to look at tangible data based on the model or the scenarios they ask us to model, of course, but tangible data and make the right business decision, especially in industry when you have a lot of when it's a capex heavy sectors like aerospace, as I say, steel, etc., etc.
Excellent. So I'm just kind of conscious of the time here. I do want to see if we've got questions from the audience, but one of the things that, so to be able to do that kind of optimization, for example, and these kinds of digital twins, can you talk, Nelson, about some of what's required?
Absolutely. And I think what's unique about what we're seeing here is the beginning of kind of an infrastructure around modeling and simulation of very complex systems, obviously, which climate risks involve. And so I think what's required is exactly this kind of functionality that is somewhat generic, that can be applied to different kinds of industries. So I think the kind of sectorization approach is going to be very interesting to see how that plays out. But I think figuring out what that infrastructure layer looks like, the data science questions, we're working with the Harvard Data Science Initiative to figure out a lot of that. The correlations, for example, to have credible decision support are going to be really important. And so I think the level of fidelity, for example, around digital twins, right? Which aspects of multi-systems simulations will we model to that level of fidelity so that we can get to not only financial decisions, but I think there are a lot of needs for business model innovation where there's market failure, and often where this extends into social impact. Right now, we depend on things like randomized control trials, right, which cost a lot of money and take decades. I think with simulation, we can accelerate that, make it a lot cheaper, and actually begin to understand what interventions are going to matter most, because we don't have a lot of time, right? So I think it's investing, it's business model innovation, but it's also some of the social impact that's really interesting around the level of fidelity that we can get through digital twins. But again, that's going to require infrastructure. As AWS, we like to think about ourselves as plumbers. So we love to be a plumber to the plumbers and let some of our customers deal with some of the last mile sector-specific solutions.
Terrific. We can't show the audience, but I do want to. We're going to go into some much deeper dives with others following this session. I wonder if you've got any questions you'd like to raise initially here, and I'll turn to the audience. Ladies first.
So, well, first of all, thank you, and really an incredible undertaking. So I have two questions. One is I didn't understand or fully appreciate what you mean by validation. And the second question, it's really a little bit more of actually a concern, is how you are evaluating this what if, which is basically what I understood is that you start with, as you explained it to me, you started with the black box model, then you try to figure out a way to have it interpretable with a series of equations, and then you modify the value of one variable to figure out whether or not, what has changed the system. One challenge in doing it that way is the fact that you don't have any control of what I call confounding variables, which could be other variables that could vary, in a similar manner as the variable that you want to act on. And so, I'm just wondering why so your what if, approach, I would say, is very non-standard, what we call in data science methodology. And so just wondering why you're doing that way versus relying on what is really more, I'll call it the state of the heart to assess causality, right, in affecting an intervention.
Let's answer it briefly.
Sorry.
No, okay. So,
Help.
what do we call validation? So, very classically, individual validation of models. Then it's a program, and as I said, it's system of systems. So we validate bricks before putting them together, and the final one, which is integrated assessment model as a whole, needs to be, let's say, thoroughly assessed by specialists in all domains. And that's what we want to do with integrated assessment model community, because here we'll find the proper panel of people who are able to look at each and every detail. Today, there might be some areas where we don't have specialists enough to be able to raise a point and say, look, guys, this is stupid. Okay, so that's that. Absolutely, absolutely. And then the second point, I think my answer will be twofold. The first one is I was a bit rapid on that, but all the coupling is done using semantics, which means and namespaces, but which means that when you are changing something by its name and in its namespace, that can be one of the scenario or one of the system, all the area where it could be used will be impacted automatically. Okay, because the coupling is not something I've not wired my model by hand, and it would be impossible. I can show you the type of diagram you get. I would not dream to do that, even. So that's the first point, and the second point is it's not propagated; it's fully converged. It's a fixed point algorithm from a mathematical point of view. So. At the end of the day, if you have, let's say, ripples effect with some coupling effects, it will come until it stabilizes completely for each of the years.
Great. I'm going to turn to the Climate Interactive team.
Thank you. And congratulations. This is really amazing and interesting, and just excited to learn about it. My name is Drew Jones. I'm the Executive Director of Climate Interactive. We build En-ROADS, and headline question is, what is your vision for the scale of open source contributors to your model? We just had a big breakthrough going from one person at a time working on En-ROADS to now 3 and 4 and 5, because we figured that out. That was a big break for us, but I'm guessing your vision is a lot bigger. I'm just curious, what's your vision for the scale?
That is a great question, and so we're going to invite Mathieu Mo to answer that remotely. If Mathieu, you're still with us.
Yes, I'm with you, and nice to meet you, Jason. First of all, I really appreciate your work at En-ROADS, and it's something that inspired us, all the team. Today we are 20 developers in the team, so we are used to collaborate together. We have what has been presented as a model DevOps. That means that we have a validation method for every model, and we can have different contributors. We tested that since 4 years with 20 developers working together, not only 1 or 5. At scale, we want anyone that wants to create a model to contribute. We will still need to have validation processes for the overall integration of models to be scientifically correct, looking at all the causality and all these causalities that will be coupled afterwards. It's very important. So more or less, we are ready to onboard hundreds or thousands of contributors if it's possible. And I think with our model DevOps approach, we are scalable and fully scalable today.
And so to do this takes a very robust computing environment and cloud infrastructure. Do you want to talk about that part, Delson?
Sure. We talked about scale earlier, and this question, we hope to have infinite numbers of collaborators doing not just open. I like the language that OS Climate uses. It's not just open data, it's open software. It's open solutions, open data science, perhaps. And for that to happen, we do need the kind of infrastructure that, for example, AWS has, but also the data lakes, the ability to sequester data in very modular ways, because open isn't always open. You can actually have open data that requires different permissions because of governance, because of in the United States HIPAA, FERPA laws, for example, and then monetization eventually as well. So I think that's really important. And then the compute on top of that is something that is really exciting too, right? Open source software that can leverage auto scale, high performance computing. I think obviously generative AI is going to be an incredible solution because it can democratize and localize and humanize data in all sorts of ways, which we're just beginning to see. And I think with something like climate risk and equity and access, that's critical. And I think Generative AI unleashes that. We're very excited that a lot of this is going to be built in some of instantiations in the Amazon Sustainability Data Initiative, which is an example of a data set of data sets around sustainability, which we will build compute on top of. And so we hope to have the tooling on top of basically what is almost infinite compute power, at least given state of the art, to enable an open source set of collaborators and to work on not just the data, but also the insight generation. We're actually doing a lot of work to automate even research workflows, right? How do we actually take away some of the undifferentiated heavy lifting of peer review and data cleanup? No ETL is something that we're big on. So really kind of taking that heavy lifting away to enable not just data sharing, but building on top of this almost infinite compute to get to collaborative insight generation, which is, I think, where the planet needs to go, obviously.
Terrific. We've reached the end of our time here, but it's the beginning, right? So this is, I want to stress that I think as Mathieu noted earlier, these years of intense work, a lot of investment have led up to this point where we're now ready to open up to scientific inquiry, to science-based criticism and improvement on a continual basis in a transparent environment. And you asked about part of the ambition here is really, I mean, the long-term vision is something a bit akin to an operating system, where on top of the stack that is built, on top of the data infrastructure that Red Hat, our IBM partner, has helped to build, and with this very robust cloud-based environment to allow top of stack decision modules for a range of different sectors to operate, and again, improve those feedback loops so that we can understand what's happening in this part of you push in this part of the economy, there's a bulge in another part, and to be able to respond. This is what's needed, really, to be able to make the big bets at the scale that are needed in the time frame that is needed to really move the global economy in a way that meets net zero goals, that is resilient, and that is just. I'm just going to end by noting that one of our close collaborators from the UK, Gavin Starks, who's one of the great leaders in doing this in the banking environment, is handing out buttons that say the time for theory is over. The time for quantification is now. That's what's needed for action, and that's what we're trying to deliver. So I want to thank my panelists just remotely, Valérie Pereira, Marie Morer, Mathieu Mo coming in from France, Thierry Chevalier, who I've been delighted to work with over these last years, Vincent Charpiot, and Nelson Gonzalez. We also thank very much the IAAI and Miroslav and his team here at the Digital Innovation Pavilion for a terrific job. And we look forward to your questions and comments and follow-ups. Our team will be looking at those incoming. Thanks again for joining us today.